Hello guys, in the today's class we shall discuss or we shall derive the force produced by two fluxes in induction cup relay as well as induction disc type relay. That derivation will be common for both type of relays. As we know, the fluxes phi1 and phi2 are responsible for producing torque in the disc. Yes or not? So it may be disc type, or it may be your wattmetric type, or it may be a cup type. We require two fluxes to produce the torque. So accordingly, and again we know that those two fluxes are alternating quantities in nature as expressed as follows. So I'm going to call one flux as phi1 and the other flux as phi2. Since it is alternating quantity, I am going to elaborate this phi1 as phi1m sin omega t, phi2 as phi2m sin omega t plus theta. Now coming to this plus theta. So this theta is nothing but the phase difference between the two fluxes. Like I told you in the earlier class, two fluxes should be such a manner that there should be a phase difference between those two fluxes, irrespective of the magnitudes of the two fluxes. So always there should be a phase difference, then only a rotating torque is produced. Thus your disc rotates or your cup rotates. So here what has happened, your alternating quantity flux phi2 will lead phi1 by plus theta. So plus theta we have put into the flux phi2. Okay. So we know that flux 1 will cause or induce voltage in the rotor, that is in your disc or maybe cup, right? So E1 is proportional to what? d phi1 by dt. So change in the flux will induce the voltage in the rotor. Rotor can be a disc or cup. So if I substitute this phi1 over here, so I'm going to get what? If I'm going to differentiate this phi1, so I'm going to get what? Phi1m cos omega t. Similarly, phi2 also will cause induce voltage E2 in the rotor. So E2 is proportional to rate of change of flux phi2. If I do derivation of this, then I'm going to get what? Phi2m cos omega t plus theta. And here you can see, here flows the eddy currents I1 as well as I2. Yes, I1 is with respect to the phi1 as well as I2 is with respect to phi2. So phi1 induces voltage E1 and phi2 induces voltage E2. So with respect to that voltage, eddy current starts to flow in the disc, and this is the disc. Okay, torque produced in an induction relay. And I2 is this. And also you can see the force due to phi2 as well as force F1 due to phi1 are both in opposite direction. Okay. So I1 is proportional to the phi1m cos omega t, because due to the EMF E1 itself, I1 is induced, that is I1 is eddy current flows in the rotor with respect to their voltages. Similarly, I2 is proportional to phi2m cos omega t plus theta. So depending upon the quantity of this, I2 will start to flow. Now we know that current produced by the flux, current which is produced by the flux, right? Any of flux to voltage and voltage to current, or vice versa you can call. Therefore that leads to produce force F1 as well as F2. So F1 is due to the flux of one alternating quantity as well as current of other electric quantity. What I'm trying to say is F1 is proportional to phi1 into I2. It is not phi1 into I1, because I1 as well as phi2 will interact. Similarly, phi1 as well as I2 will interact to produce the force F1. It is not I1 and phi1 will give rise to F1. It is I1 as well as phi2 will give rise to your F2, whereas your phi1 as well as I2 will give rise to F1. So due to the interaction of those two different quantities, that is alternate quantity of phi 1 as well as alternating quantity of second, that is phi 2, that is I2, will give rise to force F1. Interaction of two different fluxes you can call, but one term we have taken it as flux, alternating flux, another term we have taken it as current I2. So F1 is proportional to phi 1 into I2. It's a product of alternating quantity 1 as well as eddy current due to the phi 2, that is I2. Now I am going to substitute this phi 1. Already I know what phi 1 is. Phi 1 is equal to phi 1m sin omega t. I have substituted here. I2 I am going to substitute over here, that is phi 2m cos omega t plus theta. And again I am going to rearrange this phi 1m phi 2m cos omega t plus theta into sin omega t. We are good at it, right? Now coming to phi 2, coming to F2, similarly F2 is also due to the alternating quantity phi 2 as well as the eddy current due to phi 1, that is I1. So it is product of alternating quantity phi 2 as well as the eddy current I1. Similarly, I am going to substitute the value of phi 2 here. So phi 2 value we already know that phi 2 is nothing but phi 2m sin omega t plus theta, and I1 is already we know it is phi 1 cos omega t. Again I am going to rearrange this phi 1m phi 2m sin omega t plus theta into cos omega t. As we know that F2 and F1 are opposite in nature, you can see both are facing each other, so the resultant will be what? Difference of it, right? So F is equal to F2 minus F1, means resultant forces can be achieved. So I am going to substitute all the F2 values here as well as F1 value there. So one thing is what common in F1 and F2 is phi 1 as well as phi 2m. So phi 1 phi 2m you can see there I have taken them outside of the bracket. So inside bracket what remains is sin omega t plus theta cos omega t minus cos omega t plus theta sin omega t. So this is in the form of sin of A minus B. Sin of A minus B, sin A cos B plus cos A, sin A cos B minus cos A sin B. So this is A and this is B and this is A and this is B. So A minus B in sense what? Omega t plus theta minus omega t. So omega t gets cancelled, so remains is theta, so it is sin theta. Hope you got this. So if you want to remove this suffix m, means you can remove while writing the expression. So K is what? Constant of proportionality, that is K. If I want to report the proportional sign, so F is equal to K phi 1 phi 2 sin theta, where phi 1 and phi 2 are the RMS quantities or values. Since we are believing the fact that both quantities are different, if they are the same in magnitude, means that can be written as I, or it becomes K times of K into I square sin theta. If we believe I1 is equal to I2, then what happens? Phi 1 will be equal to phi 2. So in that case what happens? It will be F is equal to K into I square sin theta. If both are different quantities, if you want to represent in another form, then you can write it as like this also, Kmn sin theta. M is due to phi 1 and N is due to phi 2 and sin theta remains as it is. So F is equal to Kmn sin theta. So this is the expression for force due to the two alternating quantities in induction relay as well as wattmeter type of induction relay as well as your cup type induction relay. So now we shall move to the next topic, that is static relays. So static relays are those which make comparison or measurement of electrical quantities by using static circuit. Yes or not? We discussed this already. So which gives an output signal to trip the circuit. So nowadays static relays usually use a DC polarized relay, like I told you earlier, which acts like a slave relay. Its only function is to what? Close or open the circuit. So it does not functions like comparison, like I told earlier. It doesn't make comparison. It always closes or opens the circuit. So it is called as slave relay. And now we are going to use such relays because of its low cost. And nowadays they are most reliable when compared to that of your electromagnetic relays. So these relays include semiconductor diodes, transistors, or it may be Zener diodes, or it may be logic gates as its components for its operation. So looking at all these advantages, one thing is for sure, these static relays will surely override all electromagnetic relays. That is, all electromagnetic relays will be replaced by static relays. So let's see now merits and demerits of static relays. So let us discuss first the advantages of static relays over electromechanical relays. So at the first we have, you can see it is a low burden on CTs as well as VTs. So low burden in the sense what? Low voltage ampere on the secondary side of the relays, as it consumes very less power, so that auxiliary DC supply is required. So it was not in our case with our electromechanical relays, it used to consume more power as well as burden is more when compared to that of your static relays. So there is very less burden in the on CTs as well as VTs. And the second, you can see it is fast response, so that matters a lot for any relay. Third one, long life, can expect long lifespan by using static relays. Fourth one, so it is very resistive to the shocks as well as vibration. Even your there are shocks, the environment is like which contains shocks as well as vibration, there also static relays fits. So maintenance cost is less, because as there are no any moving parts as well as bearings, just like we found electromechanical relay, you found disc there, bearings, ball bearings, spindle, either it may be cup or disc type, but here there are no any such things, so maintenance is absent. You can't say zero maintenance, but you can say less maintenance. So frequent operations we can perform without any deterioration. Next one is quick resetting and absence of overshoot. There are no any overshoots. Overshoot and all you have learned in the control system. Next one is the compact size, small in size, and the sensitivity is greater here when compared to that of your electromechanical relay. And the complex relaying characteristics can be easily obtained. Next one is the logic circuits can be used for complex protective schemes. So these are some of the merits which you can remember, or you can call advantages of static relays over electromechanical relays. Next, the demerits part of the static relays. As we know that it's a static device, so it is very temperature sensitive. So characteristics of such relay may easily change with respect to variation in the temperature. So temperature compensation is very important here by using thermistors and also by using any other digital techniques, so that temperature is maintained proper. And also second one is, second disadvantage, static relays are sensitive to the voltage transients. So semiconductor components may easily get damaged here, because due to the fluctuations or voltage spikes. So it is expected to have filters as well as any other shields for such voltage spikes, against voltage spikes. So third one again, static relays, like I told you, auxiliary power, DC power it requires. So this again we need to have a separate battery or a stabilized power supply, so as to give auxiliary power supply to the static relays.